Okay, hey soapy folks. I'm doing a video today, a little different than my normal soap videos. I did make soap, as you can see. I have some things here, but this is a little different. So I am interested in making a shaving soap, and what it boils down to is I don't know like the perfect recipe for it, what makes a great shaving soap. If you read, there's lots of shaving forums out there, and there's lots of opinions about sort of what is a good shaving soap and what isn't, and what's in it and what isn't in it. But there are some variables out there that people talk about, and I thought I'd do some testing of those and see what the results were. Now, your choice of oils is kind of your choice of oils. Just like if you were making a bath and body bar and you decided, you wanted to make it super luxurious and you think that, goat milk does that and you decide to put goat milk in, then great. So the oils themselves are kind of what the oils are. I'm not really worried about the oil composition in my testing tonight. So I have a very basic recipe, and you can kind of see it over here. 0.5 of beef tallow, 0.5 of coconut oil, 0.5 of cocoa butter, and 0.5 of stearic acid. Now, one of the variables, and what we're testing on this first row, is the breakout of potassium hydroxide to sodium hydroxide. So a shaving soap normally uses both of them, as opposed to a bath and body bar, which just uses the sodium hydroxide. And I know that you can make liquid soap with potassium hydroxide, although I've never done that. So I decided to do some testing of some different breakouts of the combinations. So my first soap is 40-60, then 50-50, then 60-40, 70-30, and 80-20. And then I did all the calculations for them. Now, I will say I made a mistake. I actually did this recipe using castor oil, but then when I got down in my kitchen, I used coconut oil, and it was just a total, senior moment, I guess. So my numbers, if you look at these numbers and then you go into Soap Calc and you look at them, these numbers are actually based on castor oil, not coconut oil. So they're slightly different. They're still pretty darn close. I think the sodium was 0.28 and the potassium was like 0.4. So I did mess up a little bit. But again, I'm really looking at the effects of the breakout of the different percentages of sodium and potassium. And, I'm not in a lab or anything, so this isn't as scientific as it can be. It's, in my kitchen. So here's the first row. Now, this is only a few hours after I've done it. I started around 6:30, and it's 9:45 now. So it took a long time to measure out all these tiny amounts and then put them together. And I didn't use a stick blender, so that's one thing. So starting over here, this is 40% potassium, 60% sodium, and you can see it's really hard. It's only a couple hours old, and I can take it out and look at it. This one's really hard too. This one is 50-50. This one's very hard too. It's 60-40. Now these two are very soft, and this one is 70-30, and this one's still liquid, and it's 80-20. So those are the different combinations. Now I'm not going to try to lather them or anything. I'm going to let these sit for probably 24 to 48 hours and then come back and test them with a brush. So that's the first variable I'm testing, is the breakout of percentages of sodium hydroxide to potassium hydroxide. In the back, and there's my kitty. Psst, psst. She's always curious about why I'm talking to myself in the kitchen. The next variable that gets talked about a lot is the percentage of stearic acid. So shaving soaps contain a lot of stearic acid. You want a soap that is creamy and conditioning and creates a lather that lasts a really long time. You don't necessarily want one that creates lots of bubbles or is cleaning. Those are not as important in a shaving soap. And you can obtain a lot of those results by having a lot of stearic acid. So when you're choosing your oils, you definitely want to look at oils that contain lots of stearic acid. And traditionally, things like animal tallow were used to make shaving soap, and that's why I made my very basic recipe contains beef tallow just to do some testing. But you can look for other oils that are high in stearic acid as well. But most recipes that I've read about or talked about in terms of when you're creating a shaving soap on your own use actual stearic acid. Like you buy stearic acid and you add it to your recipe. So that's what I did. I used the same recipe here, starting as my base, but then I changed the percentage of stearic acid. And I did the calculations for that. So as you can see here, I have a 20% stearic acid, 30%, 40, 50, 60, and 70% stearic acid, and then changed all the numbers. Now the same thing applies. I did the calculations based on castor oil, but ended up using coconut oils. So these are a little bit not what they should be. But again, I'm really more interested in sort of the breakout of the percentages. So starting way over here, we have 20% stearic acid, which is looking, it's soft, but I mean, it's kind of firm. Now these aren't very old at all, so then 30% is a little soft too, 40%, 50, 60, and then 70. Okay, and so you can also notice sort of that the volumes changed because I was adding more and more stearic acid to them. Now these last two, just one sort of note about them, I kept heating the oils in a Pyrex measuring container and then adding the lye mixture and stirring them up. Well, by the time I got here, I was a little impatient, first of all, but also my Pyrex container was really hot and my oils got a lot hotter than the ones over here. So when I poured in my lye solution for these, it was almost like a hot process. It sort of bubbled up and volcanoed, and I had to stir it down. So I don't know if that will make a difference either, sort of as a major variable. But these two also contain a lot of stearic acid, so I'm expecting them to be, I don't know, sort of very hard. But in some of the forums I've read, people have talked about using stearic acid in these kinds of high concentrations. The ratio of sodium hydroxide to potassium hydroxide was the same in this back row. I kept a constant 60% potassium hydroxide and 40% sodium hydroxide for this, right? Because I'm testing the percentage of stearic acid. This one, the stearic acid remained the same in percentage. It was 25% of the recipe, but I was testing the breakout of the concentrations or the ratios of potassium hydroxide to sodium hydroxide. Okay, so that's my little science experiment. It's on this little tray, which doesn't seem like a lot of work, but it took like 3 hours to do all that. So anyway, I'm going to let them sit for 24 to 48 hours, and then I will have so after the break should be the video, and I plan to get my shaving brush and then come back and see when they're all nice and firm, or if they're firm, what the bubbles sort of look like, and then that will be the second part of this video. Okay, thanks a lot, and hang around for, after the break, the bubble testing. Bye. Okay, everyone, so this is follow-up to the shaving soap. It's been about close to 20 hours, so I'm going to do some testing with my shaving brush and see how the different soaps kind of react. Okay, so I'm going to start with the differences in the ratio of potassium hydroxide to sodium hydroxide. So I'm going to do those first. So this one is 40% potassium, 60% sodium. Okay, so I mean, not bad. It feels soft and creamy and okay. All right, so we're going to move to the 50-50 one. So half potassium and half sodium hydroxide. All right, so it seems a little bit easier to get lather here. It feels exactly the same to me. But this does seem kind of thicker, a little bit. Okay, next is 60% potassium, 40% sodium. And this is, in my other shaving video, this is the percentage breakdown that I used for that one. And when we get to testing the stearic acid, this is also the percentage breakdown I used. All right, this definitely makes suds a lot easier. I mean, it started to foam up right away, and it seems to be making a lot more pretty quickly. So that was pretty fast. That was a lot easier to make suds than those other ones. Okay, and those three are both very hard, even though it's only been about, like I said, I don't know, somewhere in the 18 to 20 hour range, something like that. This one is 70% potassium and 30% sodium, and I don't know if you can see that, but it has a little bit of a different texture too. It's kind of ricey looking, and I don't know if that's simply because I didn't use a stick blender, but it's also a lot softer. I can definitely push my thumb into it and leave imprints, whereas the other one, like the 60-40 one, I can't. It's hard. I can't do that. So I'm going to try this one even though it's very soft, and see what happens. Okay, well, I'm definitely not getting sort of that welling up immediately that I just had with the 60-40 one. This does seem very creamy though, but I'm not really getting volume with it. It feels the same, I would say, like in terms of, well, that's not true actually. It feels a lot sort of thicker, more like a lotion, than the foamy lather kind of stuff. Just a little bit. Alright, I don't know that I can even test the last one, which is 80-20. because it's still pretty liquid. So maybe I'll put a little in my hand and see what I can do here. Okay, so there is soap underneath the liquid. Maybe I'll just pour the liquid off. Okay, so I just poured the excess liquid off, and this is also very soft. Okay, but let's try. Okay, this is very similar to the 70-30 one. In fact, it's not even quite as good. I'm getting kind of no lather. I mean, there's a little bit there, and it's definitely it's sort of more creamy than anything else. This one actually doesn't even feel as good. It doesn't glide on quite as easily. So, now of course these are just sort of my subjective opinions, you know, just from testing them here. So the 60-40 60% potassium and 60% potassium and 40% sodium, definitely seemed to be the one that was the best. And although, you know, these other two did pretty well, the first two, they did pretty well as well. And I have read one other posters on a blog somewhere that said they used 65% potassium and 35% sodium, and I bet you that works pretty well also. Alright, so let's go looking at some of the stearic acid ones. So if you remember, we looked at the different percentage of stearic acid for a soap. So starting with 20% stearic acid, there it is. It's very firm, but it has a little bit of give. Like I can press firmly and leave an indentation. 30% stearic acid, kind of the same thing. I could press really firmly and leave an indentation. 40%, very much firmer. I'd have to press really hard, but I could indent it if I really needed to. 50%, this is also very similar to the 40. I could press really hard and probably leave an indentation. 60%, this one's very firm. Now, it was harder to get in there, so I have some very small amounts, but in this big section, it's very, very firm. And then 70% stearic acid. This is also very firm. Now, and the stearic acid seems to give a very white bar. I have no colorants in here, and it's just cocoa butter and coconut oil and stearic acid and what was my other one? And beef tallow. So, alright, so let's see how these sort of react. Alright, so this is the 20% stearic acid. Although these plastic cups are a good setup for doing lather. They work really well. Okay, so not a lot. I did that pretty vigorously and not getting a whole lot there. All right, so 30% stearic acid. A little bit better. You can see my kitty jumping by. All right, 40%. Okay, I don't see a whole lot of difference here from the first two. And I should say that the first test I did, these down here, where I was looking at the percentage breakdown of potassium to sodium hydroxide, they were all made with a 25% stearic acid content. And I'm going to clean my brush out here with some soap. It feels like it's getting a little oily. This is a goat milk soap, which lathers pretty well. Okay, that's feeling a little better. Okay, so 50% stearic acid. Well, interesting. I mean, that seems to be making some better lather. So that seems better than the other ones. All right, this is 60% stearic acid. Well, I mean, this makes a lot of bubbles here pretty quickly. I mean, that's definitely different. I mean, okay, and finally the 70% stearic acid. Okay, so 70%. This also makes copious amounts of bubbles, or lather I should say, not necessarily bubbles. The bubbles are very, very tiny, but that makes a lot of lather. Okay, so it seems like higher content stearic acid does make for better bubbles. Now, my brush was a little oily after doing these down here, so let me clean it out one more time with the goat milk soap just to clean it. And then I want to just quickly try the 20% stearic acid just to make sure it wasn't something, because after I cleaned it, I did the 50% and that seemed to make a lot of bubbles as opposed to the 40%, but I want to make sure it wasn't my brush. So let me try the 20% again. Okay, so that's 20%, and you can kind of see it doesn't really do a whole lot. Okay, and let me go back to the 50%. Okay, so that's that. Alright, and just for comparison, 70%. Okay. Alright, so there's 70%, which makes a decent bubble and lather, and there's 50%. There's not a whole lot of difference between the 50 and the 70. They both seem to make it, but there's definitely a difference between like the 50 and the 20. So let me do the 40. one more time here. It seems like 50% was sort of the line in the sand. I mean, I'm doing this pretty vigorously. Well, I got a little bit more. So that's pretty, I know it's hard to tell, but from the video probably, but I did get lather in here, but there seems to be, to me, a little bit of a difference between this and the 50% stearic acid. This was sort of easier to get, but so there's definitely a difference between the 20%, the lower amounts, the 20%, and the higher amounts. It does seem like the higher amounts give you more lather, but it's not a lot. It's not sort of something overwhelming to me. Like, I can say there's definitely a difference. It feels like there's a difference between it definitely feels like there's a difference between sort of the 20 and the 70. Like, that seems to me like there's a difference. But sort of in the middle, there's not a whole lot of difference. I think what I'm going to do next, I'm going to turn off the video and come back, is I'm going to lather these up and let the foam sort of sit in here on each one of them, and then pause this for like 20 minutes and see kind of what happens to the lather. So I'm going to pause this, come back after the break, and check out sort of the stableness of the lather for them as well. Okay, be right back. Okay, so I took a pause, and what I did was lather each of the soaps, and then you can see I kind of put a dollop on top of them, or for these I sort of scrape them against the side. Now, the ones in the back have actually been sitting there for about 30 minutes, and the ones up front about 20, some a little bit more. But as you can see, like, the lather is very stable for all of them. So this is the 40% potassium, 60% sodium, and that's 20 minutes later, and it's pretty much unchanged. And all of them that were that way, even up to the 80% potassium, 20% sodium, that lather is still nice and mounded. It really didn't go away. And the same can be said for the sodium, or the stearic acid. So the 20% stearic acid, I scraped it against the side and it's still there, and the 70% is still there as well. So I don't, in terms of stable lather, none of these variables seem to matter very much. The lather itself is all pretty uniform. Now, if you were to repeat my test, I'm sure some of your mileage may vary. I have a certain strength when making the lather itself, the water content in my, hey kitty, get out of here, come on. Sorry, that's my other kitty. The water content in your brush may be different than mine was. All kinds of variables in there. Again, this isn't, super scientific. It's some kitchen testing. So, the lathers themselves, I can't really see a difference in terms of either the percentage breakdown of potassium hydroxide to sodium, or in the stearic acid content. They all feel about the same in terms of the difference in I don't really see a difference in the feel. They all feel very similar. They all have kind of a nice slippery feel to them. And this one over here is actually the soap I made in my other soap video that has fragrance in it and has a mixture. It has some avocado oil in it. And so this foam, this lather, has been sitting here for about 25 minutes too. And it feels very similar to me. But this one smells much nicer. So, okay, so there you have it. I'm going to leave these sit for probably a week, at least a week, and then I think I'll come back and do another video and retest some of the things I've done here just to see how they stand up over time. So I don't know that I have any final results. I'd say the mixture of around 60% potassium, 40% sodium seems to be around that level is when the foam was a lot easier to produce. You can see they all made lather, but in terms of using the brush and making the lather, this is kind of where I felt a difference. The stearic acid percentage, I don't know that I can really say that there's a big difference there in terms of producing the lather or in kind of the quality of the lather. I feel like there's a little bit of difference as I go up in terms of the percentage, but not a ton. Like, I mean, 70% stearic acid is a lot of stearic acid in a soap. And I don't think there's a big enough difference between that and even the 20% stearic acid to say you make a better shaving soap by making 70% of it stearic acid. I think like the lather itself is very, very similar in terms of that. I have a little bit of an opinion here that this 60-40 breakdown, or somewhere in that range, is a better percentage mixture than definitely the lower end. These were harder to make lather, although you can see they make nice stable lather. And then after that, one, it doesn't seem any different. It was just as easy to make this lather in the 60-40. And then two, these soaps are much softer than this one is. These are definitely going to take a lot more time to cure if they even do get harder. So I would say around this 60-40% breakdown is a good one. And then the stearic acid content, I'd leave it up to you. I think for me personally, I am probably going to stay down toward the lighter end simply because that's an awful lot of stearic acid to add to a recipe. I should also mention, I try to be a palm-free soaper, but I'm still all new to this, and without even researching stearic acid, it didn't even dawn on me that stearic acid is usually produced from palm. So right now I'm currently looking for a source of stearic acid that is animal-based, and if anybody knows that, I would love to hear it. Because I really prefer to be a palm-free soap producer. So anyway, anyway, so that's it. And then I think the bigger variable, or what makes a soap probably better in terms of a shaving soap, is your own recipe. Like, do you put in avocado oil? Do you put in mango butter? Do you put in other fancy oils? That mixture, I think, is what makes the shaving soap probably better and more appealing in terms of the lather and the face feel than, let's say, the stearic acid content. Although down here, definitely I think the mixture, the ratio of those two makes a difference as well. So, okay, that's it. I know there's a bunch of people interested in shaving soaps. If you have comments, questions, I would love to hear them. I'm sort of obsessed with shaving soap at the moment, so I'd like to talk about it. And if you liked my videos, please subscribe and check back for more soap videos. Okay, thanks. Oh, and look for probably a video in a week or two for a follow-up of the same testing. Okay, thanks. Bye.